Hey guys, it's Solbyte, and today we're going to be going over abstraction in object-oriented programming. So last time we went over inheritance, and inheritance is pretty crucial to abstraction and my next video, which will go over polymorphism. So make sure to go watch that if you haven't already. If you did already watch the inheritance video, or if you just already know what inheritance is, abstraction will make a lot more sense as far as just its functionality. So make sure to go and watch that. So yeah, so what exactly is abstraction? For the most part, abstraction you can think of like hiding complexity from the end user in a way, hiding complexity so that way it's easier for other developers to come in and be able to implement whatever is needed. So abstraction is really important, and it's just a really good practice to keep clean code, keep clean code, and yeah, just be able to use object-oriented programming efficiently. So it's better to, or it's much easier to kind of give you guys an example of what abstraction is rather than explaining what it is, because abstraction is in of itself abstract. Yeah, so today we're going to be creating one abstract class, and I'll go into this in just a second, and then two derived classes that will basically provide the implementation of a method from the abstract class. So let's go into the abstract class first. So what exactly is an abstract class? So we'll create a character class here, and we will use the access on modifier public. And so an abstract class is basically a class, by its definition, that has a pure virtual function. So if you don't know what a pure virtual function, basically it's basically a function that is saying this function, this method, is not supposed to be implemented in this base class or in this abstract class, because character is also in this program, technically going to be a base class for the rest. So basically, the pure virtual function is promising that the implementation of this function will be defined in these derived classes. But both of these classes will share the method, but they just have to define and implement it themselves. So let's just kind of show a little bit of an example. So let's make a function. Let's do a function that returns a double. And let's say we're creating like a game. So let's do like a power stat, right? We'll do something like that. And then the way to show that it is a virtual function is using this syntax. We have to set it equal to 0. So basically this right here has no implementation. There's no functionality of this function yet, but it will be shared with these classes down here. But because the power stat, for example, or how the power stat is calculated, will be different for both of these derived classes, it's good to give it a virtual function and then let the implementation be done in these classes down here. And whenever the virtual function is created in our character class here, it now makes this class an abstract class. And there's one very important rule about an abstract class, and that is that we can no longer create objects with this class. So if I come down here and I try to create a character object, let's call it soul, we get this error that says the object of an abstract class type character is not allowed. So an abstract class cannot create an object. Only these derived classes that have the implementation of this pure virtual function. And I think in a later video I will go a little bit more in depth about what a pure virtual function is. There's a little bit more to it that I could go into, but for the sake of just understanding what abstraction is, it's good to kind of just leave this here. So, all right, so now let's create the knight class next. So let's go ahead and do class knight, and we're gonna have it inherit from the public the public methods, sorry, from the character class. So perfect. Then we'll go ahead and do an access modifier as well. So let's see here. We basically defined that there will be a power stat function that will return a double here in the character class. So now we need to provide the implementation of this function. So we can do that by just doing double power stat. So writing the name, how it needs to be how it was in the character class. And then we can add the keyword override. If I can spell it, there we go. So this kind of just tells the compiler that this function here is to be overridden from whatever is written in here. Because we'll go into more of an example during my polymorphism video about how you can actually technically have some kind of functionality for this function up here, but depending on the derived classes, they could be overridden down here. And if there is no function here, then it will just do the functionality from up here. So we'll go into more of a detailed look with the polymorphism video, but for now we're just going to keep things simple and just kind of override the function for each of these classes and just go from there. So for the sake of simplicity, I won't add some kind of power statistic algorithm to calculate the knight's power stat. Maybe in a later video, I'll make a full-on project utilizing everything that we've learned in object-oriented programming. But for now, let's just return a simple value. Keep it kind of simple. So let's say that the power stat for a knight is 8.5. Perfect. So now let's go ahead and do the same thing for the healer class. So we'll do healer, and then we will have it inherit the character class, the character base class. And then do public, and we'll do the exact same thing. All right. So override, and then let's have it return, let's do 4.3. Healers are a little bit less powerful, but they can heal. So they're pretty beneficial. So anyways, so yeah, now we have these two functions that do different things. However, they are defined, or they are going to be inherited from this abstract base class of character. So let's go ahead and just kind of show an example here of how we can, or showing that it actually works. So let's create a knight. Let's name him Cedric. Did I name that wrong? Great. Okay, there we go. Cedric, and this is a very basic example. I know that I don't have any constructors or anything like that. I'm just trying to show you guys the basics. So anyways, let's do healer and let's name her Mary. All right. So now let's have it where we can see Cedric's power stat, and we'll do the same thing for Mary's power stat. So let's do Cedric, and then we'll do power stat. So this should show us 8.5 whenever we print out the code. So let's go ahead and do an inline. Then we'll do the exact same thing for Mary's power stat. And let's see here, power stat and inline. Perfect. So yeah, now we have this. So let's go ahead and open up our terminal and try to actually run this. So let's go ahead and compile it and see what we can get out of this. All right, and so as we can see, Cedric's power 8.5 and Mary's power 4.3. Now, of course, these are just some basic statistics for the knight class and the healer class, but it just kind of gives you an idea. I mean, these can be full-on functions with totally unique functionality, totally specific to the healer class or the knight class. But it will, the reason that we want to use this virtual function here is so that way we kind of show that the methodology, the methods will be implemented in each one of these derived classes. And you can think of it like, because whenever we create this class knight and healer, obviously we need to implement the functionality for the power stat function or method. And you can think of this inheritance as kind of like a contract, like you're promising to provide the implementation that is derived from character, right? And of course, we can still, inherit lots of different things from character that don't need to be implemented directly here in the derived classes. But for anything that is a virtual function, we're kind of just stating that we intend to have this function for each of these derived classes, but implement them differently depending on the class. So, all right, and yeah, that's kind of a basic example of what abstraction is. And if you don't understand completely just yet, I recommend getting some practice with it. It just kind of makes the code a lot more readable. And, it's a good coding practice to do things like this just for readability and, for other developers that may come in and help with like, open source projects or, whatever else. So this is really good practice. So I do recommend learning it and understanding it. And we're going to dive more into it during my polymorphism video, which will be a little bit of a longer video. Polymorphism kind of takes away from the inheritance and the abstraction parts of object-oriented programming. So we're going to look more into this in my next video. But for now, this is just a basic example of how abstraction works. So yeah, if you guys have any questions, please let me know in the comments below. And thank you for watching.